Hi everyone. So what related rates basically is it's essentially an algebraic method that happens to involve calculus to solve certain sets of problems. So what I have here is an example problem, which I think is ideal for trying to explain related rates and the sorts of problems you will probably see. So if you happen to already know related rates, I highly suggest that you just skip to the end and see the usual summary of things that you need to know, even though it's probably not as helpful as the example itself. Okay, so please pause for a second and read the problem. Okay, so first we're told that the ladder is 15 feet long. And I have that drawn here. In fact, I have a diagram of the ladder and the wall here. So the ladder is 15 feet long. And let's call the distance from the base to the wall x, and the distance from the top of the ladder to the floor y. So the base is being pulled away at a constant rate of 2 feet per second. So constant rate should immediately give you the idea of derivative, because it's a change. So we know that the dx dt is 2. So we want to know at what rate the top of the ladder is sliding down the wall when the base is 12 feet from the wall. Or what's dy dt when x is equal to 12? Well, if you look at my diagram, you can immediately tell that we can use a Pythagorean theorem, where x squared plus y squared is 15 squared. So, since I'm interested in dy dt, I can take the derivative of both sides. So I'm left with 2x dx dt plus 2y dy dt is equal to 0. So to simplify things, let's divide both sides by 2. So now I'm left with x dx dt plus y dy dt. Okay, so now I want to solve for dy dt, but I want to solve at a specific moment in time, when x is 12 feet away. When x is 12 feet. Well, so let's make x 12. We know dx dt is 2, so this becomes 24 essentially. And we can find out what y is by solving for x at this moment in time. So we find out that y is 9 when inserted into this equation. So now I just move 24 to the other side, and then divide both sides by 9 to get dy dt is negative 8/3 feet per second. Okay, so hopefully that example gave you an idea of how to solve for related rates problems. But basic general steps that you could probably use in almost all cases, I think, in the curriculum given, is that first, hopefully somewhat obviously, you have to take note of all given information. It's actually ideal to write it down, so that you actually know what dx dt is, what dy dt is. Secondly, if possible, draw a diagram of the problem. A lot of times, related rates problems are actually based in geometry, and it's quite frequently occurs that if you draw a picture, you actually notice new equations that you can use that are actually essential in solving the problem. So 3, try to make equations involving your important variables and solve for unknowns, or at least isolate them, like I did here. And 4, use your given information to solve for unknowns and essentially solve the problem. So thank you guys. Hopefully this does explain or give at least a fairly good example of related rates. So thank you. Hope calculus is brilliant.